Hi everyone. So we will wait for next 5 minutes. Let others join as well. Then we will start off with the session today. Yeah, hello everyone. So we will start at 6:05. So let's wait for others to join as well. So hi everyone. So it's 6:05. We are good to go now. If you can hear me clearly and if you can see my screen. Just write yes for the confirmation in the chat box so that we can start off with the session. So just write yes in the chat box for confirmation if you can see my screen clearly and you can hear me. Alright guys, so hi everyone and welcome again to this webinar on building and deploying a logistic regression model. So let's get started with today's session. So it is going to be a 2-hour long session, and the first half we will talk about, so we have divided this session into 3 parts. First will be the theory part, the second part we will be building our model, and the third part we will see how we can utilize whatever model that we have built, how we can deploy it. All right, so let's get started. So this is the what we are going to learn today. So first of all, we will see what is machine learning. Then we will talk about the traditional system and the machine learning. Then we will see what are the different types of machine learning, and then we will talk about the workflow of this machine learning projects. All right, and then we will talk about the overview of regression, and then we will talk about logistic regression. We will build our logistic regression model, save it and deploy it on our local machine. All right, so if you know any cloud platform, you can deploy there as well. So let's get started and see what is machine learning first. All right, so let's see what is the idea of this machine learning here. So here we are humans. When we are born, we don't know anything, right? We don't know how to speak, how to walk, how to talk. How do we learn all these things? So we learn it from our parents, right? We learn it from our parents or our elders. We try to mimic them. We try to learn from them. We try to walk like them. We try to talk like them, right? So we are trying to learn through their experiences, and in that process we fail sometime, but we keep on trying, right? So this is your machine learning, where so the idea is generated from the idea where an infant can learn from his experience and by looking at others, right? So this is how we human learn from these experiences. Now then there are computers. Now these computers, what they do is they take instruction from humans, right? Like if I tell this computer to open a file, it is going to open a file for me. If I say this computer to play a video, then only it is going to play the video. So it is taking this instruction and then performing some task, right? Then we try to come up with systems that can automatically do this task without us giving this instruction. So here we come up with this idea of machine learning, where it learns from this data, like we learn from experiences, right? So the more data you supply in these machine learning models, the more they learn and the better result they give you. All right, so this is the idea of machine learning, which is extracted from the idea where an infant is born and then he learns, right? This is how this machine also learns. At first it makes some mistakes, then it tries to improve and learn through that mistake. So this is the machine learning here. And if you see the example here, if you go to Amazon and Flipkart, if you search for something, let's say you search for mobile, then they recommend some other mobiles based on your interest, right? So this is machine automatically doing all the task. You don't have to give this instruction. So let's talk about this definition here. So machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. So you don't have to hard code this machine learning. Alright, so you have a model, you have an algorithm, you just supply the data and it will do the job for you. Now let's talk about the traditional systems and the machine learning. So there were traditional systems as well before the machine learning came into the picture, and how they used to work. So here we used to have rule-based programs. We have data, then based on this particular data, what we used to do is we used to write programs and program them or hard code them. So here, then after this rule-based programs are fed with your data and program, then you get to have these outputs. But in machine learning, you have this all algorithms, machine learning algorithms, and here we just supply the data in this machine learning algorithms. You don't have to hard code them or tell them what to do when this particular situation appears. So you don't have to do that in machine learning. You just have a algorithm, then you apply this data, supply this data in this algorithm, and you will have the output. So this is your difference between the traditional systems and the machine learning. So why machine learning is a buzzword these days? Why everyone wants to be a machine learning engineer, or they want to work in this AI field or data science field? So why companies are also adopting this machine learning buzzword, right? Because there has been explosion in amount of data created every second with the use of internet, and businesses want to utilize all this data for their purposes. All right, so here if you talk about this data, how much data do we generate, then 2.7 zettabytes of data exist on our digital universe. So there are 2.7 zettabytes, we are talking about zettabytes of data here, exist on our digital universe. And 149,513, that is a big number, right? Emails are sent every minute. 3.8 million of Google searches are made every minute. 800 emails are constructed every minute. 500 hours of video are being uploaded on YouTube every hour. Now you see how much data we are generating through the use of this internet. We haven't talked about this Facebook, Instagrams, Twitters, and these all social media apps. Now if you consider them as well, now you think how much data you just by single person is being generated every day, or let's say every minute, right? So we want to utilize this data. We want to utilize this data for our businesses or our purpose, whatever purpose this might have, right? So this is why this machine learning is a broad field and it is being adopted by the big techs. Now, if you look at the application of some of the machine learning, here are few of the listed application. There are many more. If you can think of anything, then the possibility is that you can use this machine learning there as well in that field, be it in banking sector or marketing sector or self-driving cars. So these are applications. So you have virtual personal assistant is there. We have fraud detection system, then we can predict the stock movement, we can recognize the speech, and we have this recommendation engines that we have talked about already, like Flipkart, Amazon. These all are using this recommendation engines to suggest you the movies or the products. Then there are self-driving cars, and You can also do customer sentiment analysis here. All right. So let's see what are the different types of machine learning. We have talked about what is this machine learning, why this is buzzword, why this buzzword now, right? Now let's look at the what are the different types of machine learning here. All right. So here there are three types of machine learning mainly. One is supervised, the other one is unsupervised learning, and then we have something called as reinforcement learning. So now let's look at what we do in supervised learning here. So in supervised learning, training is done on labeled data. So we'll talk about what is labeled and unlabeled data. Output label is known to us. Let's say if you want to predict, let's say if this message is spam or not. So this is your label, whether it is a spam or not spam. So this becomes your final label, the class that you want to predict. All right, so this is your label, and then you have many features like number of text, number of links in that message, right? So these all are called features, and the final target that you want to predict is your class or label. So there are also two types of this supervised learning, that is regression and classification. In unsupervised learning, the training is done on unlabeled data. So you don't have the classes there. Like here we have this spam and not spam. In unsupervised learning, we don't have this labeled. So the machine learning algorithm tries to infer patterns from this data with reference to unknown labels. Sorry, there is mistake. There is unknown labels, not non-labels, it is unknown labels. Example, customer segmentation. Let's say if you want to segment your customer as loyal customer and disloyal customer. So here you try to see their buying pattern, how often they are buying, if they are switching from your e-commerce firm to other. So you try to infer these patterns. Then there is something called as reinforcement learning. So this reinforcement learning is based on trial and error method. So you encourage the outputs that are favorable and you discourage the output that are not favorable, right? And this is a continuous process, and your model keeps on improving. And initially it makes some mistakes, then it learns that yeah, I predicted it wrongly, then it tries to correct that mistake, and again it tries to improve. Again, if it is making some mistake, then again it tries to remove that misclassification, right? So this is your reinforcement learning here. Now let's talk about this classification and regression. So here I have this data set where we want to predict the salaries based on the number of experiences. All right, so here we have experience, and then also we are given the salary. So this is a supervised learning problem. So based on this experience, so here our experience becomes our independent variable, and the salary here is our dependent variable. And here if you see the continuous, we have this salary in numeric form, right? So this is a continuous dependent variable, and it is a regression problem. So whenever we have continuous dependent variable, that problem is of regression type. All right, and now let's look at this another example where we have this transaction amounts, and we have class as fraud and not fraud. So here your independent feature is going to be the transaction amount, and based on this transaction amount we are going to predict the classes here, whether it is a fraud or not. So here your independent variable is transaction amount, and your dependent variable, that is your class, right? We want to predict whether it is a fraudulent or not fraudulent transaction. So here, if you see, your dependent variable is categorical, right? You have a category as fraud and non-fraud, and this becomes your classification problem. So here we are mainly going to talk about the classification problems. So now let's look at the workflow of this machine learning, or the process of machine learning. So the first step is to define your problem. What is the problem that we want to solve? So here, let's say our task is to decide whether the transaction is fraudulent or non-fraudulent. So here it becomes your problem statement, right? So based on your problem statement, what you do is you go to collect your data. So this data might be present in your databases. If not, then you have to come up with some strategy to get this data, solve this problem. All right, so then you go for this data collection, and after collecting your data, there are different processes as well. All right, so the first process is preprocessing your data. So the data that you have or extracted from somewhere or from your database might have some ambiguities or noise, right? So how do we handle that? For that, we use this preprocessing techniques. So if there is some missing values, we try to fill this missing values or impute the missing values. Then we try to scale and normalize, and we do some feature engineering, and we transform our features. And here, after doing this pre-processing, what we do is we divide the data into training and testing. So on your training data, you are going to build your model or train your model, and then for evaluation, how well your model is working, we use this testing set. All right, now after this, we choose the type of modeling that we want to do, or the algorithm that we want to apply here. So here you can apply the supervised models, unsupervised models, and reinforcement models. All depends on your pre-processing and exploratory data analysis. All right, which model should you apply? If your data has a class, then you can apply this supervised model, right? If it does not have any classes, then you go for unsupervised models, right? So this you can identify only using going for this data analysis, or EDA, that is exploratory data analysis. So apply model as per your problem statement and the data. All right, then after building this model, how do we know that this model is going to work fine, right? How do we know? If we go and try to do some real job with the whatever we have built, how do we know that this is going to work fine? For that, what we do is we do this model evaluation. So we have confusion matrix for doing that, and we check the accuracy of our models. Then there are different metrics like precision and recall, and we also do the cross validation, right? Then check for whether your data is overfitting or your model is overfitting or underfitting. All right, so this all diagnostic we do after building our model, and then after this model is evaluated and you are satisfied, then you can go and deploy your model, and we will come to that part at the end of this session here. All right, now that we are familiar with all these steps or processes of machine learning, now let's move forward and work with this logistic regression model. So we are going to talk about this logistic regression model. But if you see this, there is a name. This name also has regression in it, right? So it is logistic regression. So it also has regression. If we are going for classification problems, then why the term regression, right? So first of all, let's look at an overview of this linear regression. What does this linear regression do here? So in linear regression, we try to find a best fit line, right, which can better estimate, or can better estimate our dependent variable. Let's say if you want to predict the house prices, then it should be as close to the real value or your actual output as possible, right? So this we try using this best fit line, and we try to measure this relationship using the R squared. So here our evaluation metric is R squared. So here I have this prices and size of the house, and these all are my data points. Alright, so these all are my data points. I have size and prices. Now here, based on the size of house, I want to predict the price. So we try to find a best fit line. So here, let's say this red line is your best fit line. Now here, the difference between these points and this line should be as minimum as possible, right? So this is our linear regression. Now let's look at what is the problem if we apply this linear regression for classification problems. So if we use linear regression for classification problem, where we are trying to predict whether a student is going to pass or fail, then we will get the predicted values between 0 and 1, right? Because we only have these two classes. Either the student is going to pass or fail. Now let's see what will happen if we apply this linear regression here, right? So here I have these points in red where these students failed based on the hours they studied, all right, based on the number of hours they studied. All right, so here the points that are in red, they failed, and the points that are in green, they passed the exam, all right, based on their hours of study. All right, now let's see here, if I fit this line, then we will try to fit all these points and have this minimum distances from each point, right? Now here you might say that let's decide a number that if a student is studying less than this x hours or x hours, then he is going to fail, and if he studies more than this x hours, then he is going to pass. So we decide this point here, let's say, all right. So anything below this is going to be considered as fail, and anything above this is going to be considered as pass. So here we have drawn this line cutting through your threshold, all right. Now this works fine here, right? But what if I have this data points that look something like this here, all right? So here we have the one outlier, all right. So minimum number or the average number of hours a student studies in a class, you can say that they might be studying for 2 or 3 hours, but there are some brilliant students, right, which study for, let's say, 18 to 16 hours, 16 to 18 hours. Now in order to try to capture this point, you see here, in order to try to capture this point here, this line is going to be tilted, right? And there is a more difference between the actual values and the prediction that we are getting. And if you take this x hours as your this threshold and you draw this line here, we are misclassifying these 2 points here, right? So we are misclassifying. So this is a problem, right? We are getting more misclassification here. That's why we came up with this logistic regression. All right. So here in logistic regression is a binary classification problem which is used to predict the binary classes, all right, either true, false, yes, no, cat, dog, spam or not spam. So this is mainly used for binary classification problems where you have this pass equals to 1 and fail equals to 0. And in logistic regression, we use a sigmoid function to map the probabilities between 0 and 1. And when we plot the graph, we get instead of getting a line, by using this sigmoid function here that you see, Sg equals to 1 by 1 plus e raised to power minus z here. Alright, so this is our sigmoid function. And what is z? Z is nothing but the equation of line, which is mx plus c, and here it is a sigmoid curve, not a line. And you can fetch this curve. If you have these outliers, it doesn't matter. Now here, if I set this threshold, let's say x hours, right? Here we have set this threshold, let's say 0.5, right? And anything above this 0.5 is going to be considered as pass, and anything below this point is going to be considered as fail. So here it is a logistic regression where we have transformed this line into a sigmoid curve. Alright, now that we have understood what is logistic regression, how do we know, although that we have fitted a curve here, our model is going to give some misclassification or wrong prediction, right? How do we calculate this? How well our model is working, right? Or what is the number of error we are getting by using this logistic regression model here? Alright, so here we have this cost function in logistic regression, which is L equals to minus 1 by M, and here M is the total number of data points. Then we take this summation of I equals to 1 to M. So total, for your total prediction, you are taking this summation where you have yi is nothing but your actual values into log of your predicted values, right? Yi, your predicted value, plus 1 minus yi dot into log of 1 minus yi cap. Alright, so here 1 minus your actual values into log 1 minus your predicted values, and by using this cost function you calculate the coefficient, that is M and C of this curve or your line. Then you apply this sigmoid function here, right? So now we have we know that what is logistic regression and how do we evaluate this model. All right, now let's move forward and we are going to work with some data set. We will build our model from scratch. All right, so it is going to be hands-on, and we will build this model and we will also deploy it as well. All right, so let's move to Google Colab. So we are going to be using this Google Collaboratory. All right, so here, just a second. Yeah, now if you go to your browser and just type here Google Colab, so Google Colab here, and enter. Alright, so just go to this first link which says google.research.google.com, right? So just click on this Google Colab. It will take you to this Google Collaboratory where we can write our code, we can implement this all information that we have learned, right? We have to implement it somewhere. And this Google Collaboratory, you just have to have a nice internet, right? It doesn't depend what system configuration you have, whether you have less RAM or it doesn't matter. You just have to have a good internet connection and a laptop. That's all, right? So here you see that we have opened this Google Collaboratory and we can read about all the things that we can do. And first of all, I want you all to sign in your Google account by clicking sign in here. So just click here and sign in. and it is going to ask you for your Google email and a password here. So here I'm going to give my email and passwords. Alright, so now it has opened this Google Collaboratory for us to work and implement whatever we want. So just click on cancel here, and here if you see, again you have the same interface, right? But here now you are signed in your Google Collaboratory environment. So you can use this to write your codes, implement the plots, do data analysis and whatnot. Alright, so just go to this file here. So just click on file and then on the new notebook, right? And here we are going to open this new notebook here. Alright, so here now if you see, we can write our codes here. So if you want more code cells, you can click on code. If you want to write text, we can click here on text and write something, and we will see what all we can do using this Google Collaboratory. So first of all, click on connect here, and here you can change this name from untitled fold. It is for me, so I'm going to change the name to Logistic Regression, Logistic Deployment. Alright, now let's get some new code cells by clicking here on code. Just click on this code and you will get some new cells. So we are going to need many more of these code cells here. Alright, so now that we have these code cells, now the next step will be to import all the packages that we are going to use for data analysis, pre-processing and building our model. So here I'm not going to import all the packages at once. We'll be importing these packages when we require them. Alright, so here I'm going to import packages. So just write import packages, and the first package that we need is pandas. So import pandas as PD, and the next package we will be needing is numpy. So import numpy as np here. Then we are going to need this matplotlib package to plot our graph, right? So here I'm going to write import matplotlib dot pyplot as plt, and also we are going to import the tbone package as well. So import tbone as sns. All right, so now that we have imported all these necessary packages or basic packages that are required, now let's run this. You can either click here or you can directly from your keyboard press shift and enter, and this cell will run here. So here we are getting some warnings. Just ignore this warning for now. If you run it again one more time, you won't be able to see this warning as well. Alright, now that we have imported all these packages, the next step should be to import or have our data, right? How do we read this data from our whatever places we have stored, right? For example, I have stored my data on my drive. You might have stored this on your system, right? So here if you see, there is this folder icon. So I'm going to click on this folder icon here, and then if you see on the top we have these three options, right? So here if you go and hover over all these icons, this is for your mounting drive. So if you have stored your data set in your drive, then you can mount it, right? Also, if you have stored this data set if in your system, you can click here upload session storage, and here it will be uploaded. All right, so here I have my data set in my drive, so I'm going to click drive, and then you have this pop-up which says permit this notebook to access your Google Drive files. So I'm going to connect to Google Drive. All right, so we have mounted this drive now. As you can see, we have this option of drive. Now if you open this drive, just click here on drive icon, then on my drive, and here I can go to the folder where I have stored my data. So we are going to work with this Titanic data set. All right, so we will be deploying this, building the model and deploying it as well. So here I will do a right click, and then I'm going to copy the path here. So just click right click and copy path, and now to read this data we are going to use this pandas function pd.read. So here I'm going to store this data equals to pd.read underscore csv, and within braces we can paste this path here. All right, so now let's run it by pressing shift enter. So we have run this. Now let's look at the data set. How does our data look, right? So to have the top view, so let's look at the top 5 rows of data set. Here I can write data dot head, and here I have this a look of this data here. All right, so here in our data set we have this passenger ID, we have survived, we have P class, that is passenger class, then name of the passenger, then the gender of this passenger, then age, then SIB-SP is number of sibling, then parts, that is parents, then you have ticket, fare, cabin, and all these features here. All right, so now we have to identify our dependent as well as independent feature. So here we are going to predict what is the chance of a person surviving this Titanic. All right, so we have this feature here which is survived, and here we have 0 for the person. If the person died, then it is marked as 0, and if the person survived, then it is marked as 1 here. All right, so now let's move forward, and here we had seen this data. Now let's look at what is the size of our data set. All right, so here let's look at the size of our data, and to see your size of data you can write data dot shape, and it will tell you how many rows you have in your data and how many columns you have in your data. So if you want to have this data set, you can take this data set from Kaggle or machine learning repository, that is UCIML, and there are many more places. If you just Google it, you'll be able to find this data set. All right, so now that we are aware of about the view of this data and the shape of this data, which is 891 rows and 12 features or your columns. All right, now the next step will be to have a look at all the information regarding each columns, right? So check the info. So next step is check the information of your variables, right? So check the information, and to do that you just have to write data.info. And here we have all this information of our data set. All right, so here we have this information. So it is giving us class, and the class is pandas.core.frame.data frame. So it is a pandas data frame. All right, and here you have this range index. So it is ranging from 891. We have 891 entries, and it is ranging from 0 all the way to 890. Right, so here in Python the indexing starts from 0, and now here it says that data columns, total 12 columns. So we have total of 12 columns here. So we can see all the information regarding each of these features here. All right, the number of non-null count and the data type to consider. Here you have 0, passenger ID 891, non-null, and it is the int64 type. And similarly, if you want to check what all types are present in dataset, you can have a look here, which is key types, and also it tells you the memory uses. All right, now let's move forward. And here, now that we know the information, we are going to check the description of this dataset. So to do that, you can write check. So I'm just commenting this so you will be able to refer to it. Check the description, and here you can write this as data.describe. And if you run this cell here, you're going to get all this information. So here if you see, you are going to get only the information for your continuous variables or integer and floats only. So you have this passenger ID and survived, as it is encoded as 0 and 1, right? So you have P class, then age, then CBSP, parts, and fare. And here you can have the look at your count, mean, median, minimum, 25 percentile, 50 percentile, 75 percentile, and max. So here let's consider this age. If you see this age here, the mean age for the passenger on board this Titanic is 29.6. Let's say 30. All right, so the mean age of the passenger that were on board this Titanic is 30, and with the standard deviation of 14.52. And if you see, the maximum age is 80 here, and the minimum age is 0.4. So this might be a baby that is 4 months older only. All right, so you can check all this information. Now let's say if you want to also check all the information for your categorical variables as well. So here you can give this include equals to all, and if you run this now, you have all this information for your categorical as well as your numeric variables, right? And here for your categorical variables, you are going to have this information for your frequency and the top values that are there in this variables here. So you can interpret it and write it. So yeah, so we have checked this description now. Now the next step will be check the number of null values if there are any. So we want to check the null values if there are any null values in our data set. Right, so let's do that, and here we are going to check null values. And to check this null values, all you have to do is you can write data dot is null. So here if you just run this data dot is null, it will give you true and false only, right? So you are getting this false, 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 because these values are not null, and wherever you have this null values, it will be true. So here I can see, here I have this true, here I have the true, right? So these are the null values, but we don't want this true and false. We want to see in each column, that is in passenger ID or survived or P class, what is the count of null values. So for that, after writing this data.isNull, and you can give dot sum, and you will have the count of this number of null values in each of these features or columns here. So here we have this passenger ID, right? And if you see here, there is no null value in passenger ID, survived, P class, name, text, and in age we have 177 missing values, null values, and in cabin we have 687 missing values, and in embarked we just have 2 missing values. Now if you consider this, if you see your data.save, so we have checked this data set, right? It was 891 here. So we have 891 values or rows, and out of this 891 here we have 687 missing values. So this is not going to add any value to us, right? As most of the values in this cabin are null only. So this is not going to help us. So what we will do is we will remove this feature, right? And similarly, if you come here on age, then you have to come with some strategy by going to your data analysis or doing some kind of stuff, right? You have to do a bit of research here, and you can fill this missing values, which is age, right? And in embark also we have 2 missing values. So it's your choice, either you can keep them or fill them with something, or you can just drop them. All right, so now let's fill this missing values first, and here let's fill this missing values. Fill missing values. So here we are going to fill the missing values for this age and this embarked only, right? And we will remove this feature, which is cabin. There are other features as well we are going to remove. That's why I'm not doing this operation here. First of all, let's fill this age and embarked. So here to fill this, you can write data dot fill na, and here I'm going to fill this age with the mean. All right, so here the mean was around 30 something, right? So we are going to fill the missing values in age with mean. So here I can give this dictionary, and here the feature name. The feature name is age, and here we want to fill it with mean. So age, so we want to fill data age dot mean. All right, so we have filled this age. Now we are going to fill the embarked here as well. All right, so we have just 2 missing values, and here we will fill this with the top count. So here if you go up and check your description, and you will see what was the top count. Let's go up. So it is S here. All right, so this is S, which is having the top count, or you can say this is our mode as well. So here we are going to fill this embarked. So embarked going to be filled with S. All right, so now if I run it, and if I don't write one more code here, that is in place equals to true, then these changes are not going to be reflected in your original data frame. All right, so to make these changes in your original data frame, you can give this in place equals to true. Now if you run this, now we have filled the missing values. How do we check that? To check that, we can again run this data.isNull.sum. Let's run it, and here if you see, we don't have any missing values now. We only have the missing values in cabin, that is 687. All right, so yeah, so we have filled this missing values. Now we are going to remove some of the features that are not useful for us in building this model. So if you go Yeah, hi. So there was some technical fault. We have resolved that. Now let's move forward. Right. So here, if you have this data set, we have filled the missing values. Right. So after filling this missing values, next step is to delete some features that don't add any values to us. So here we have this passenger ID, right? And this passenger ID is not going to add any value to predict whether the person is going to survive or not, right? As it is a unique identification number just given to this passenger maybe, or just a serial number to have the count here, right? So here we will remove this passenger ID. Then if you have this name, then by this name you can also not tell. Yeah, so we are having some technical issues. I don't know why we disconnected. So can you confirm if you can see my screen and you can hear me? Just type yes. So yeah, let's move forward. Right. So here we have done this imputation. Now we are going to remove some features or unwanted features from here. All right. So here we have these features name and passenger ID which are not adding any values, right? And we also have this ticket, and we have seen that Kevin is having most of the values as null. So we are going to remove this passenger ID, this name, then your ticket, as this is a unique ticket number only, and then this cabin. So how many features do we have? We have ticket, that is 1, 2, and this is 3 and 4. So we are going to remove this 4 features from our data set here. So here I'm going to write, let's check our data dot columns first, so it will be easy for us to write this code here. All right, so here we are going to drop this columns which is passenger ID. So remove unwanted features. So here we are going to drop this features. So I'm going to write data, let me zoom in a bit. Yeah, data dot drop, and here we are going to give this list of the features that we are going to delete. So we are going to delete this passenger ID, comma, then we are going to delete this name, right? So we are going to delete this name as well. So name, and then we are going to delete this ticket, as this is a just a unique number given to this ticket, right? Remove this ticket as well, and then we are also going to remove the cabin, as it is having a large number of null values here. And here you have to give this x is equals to 1. So you are telling that, so you want to delete this columns only. All right. So and also we want to reflect this in our original data set. So in place equals to true. And now let's run this. So passenger ID, the here the D is in small letter. So just change that, and now we are good to go. Now if you check your data dot head, and here you have this head of this data set, we have removed the unwanted features, we have done this missing values imputation, right? So this is your pre-processing stage where we are pre-processing this data set here. So now we have this survived T class, and this age, sorry, sex, then age, C best P, parts, pair, and this embarked feature, right? So here if you see, apart from this 6 and your embarked, all of these features are in numeric values, right? And here these two features, which is 6 and embarked, are having these categorical values. So what we are going to do is we are going to transform them into numeric forms, as our machine learning models we cannot apply this algorithms, or we cannot supply this categorical data in our machine learning models. All right, so let's do that. And to do that, we can map them. You can use one hot encoding or label encoding. There are many techniques that you can apply here. So here we are going to keep it simple, and we are going to apply or map these values here. All right, so here you are going to map this data and your text feature dot map, and here you can pass this value. So I want to map this male with 0 comma, we want to map female with 1, right? And here you have to update this in your original column here, feature here. So data sex equals to data sex dot map your male to 0 and female to 1, right? Similarly, we are going to do it for this embarked as well. So embarked equals to data your embarked dot map, and here again you can pass this a dictionary. So we are going to map this S with 0, and here we are going to map this C with 1, and we are going to map this Q. So there are 3 unique values. You can check that, right, by using different method, that is value counts or unique. So you can check that there are 3 different unique values in this embarked features. So here the other one is Q, so we are going to map it with Q. All right, now let's run this, and we have mapped this values here. All right, now if you check your data dot head, so if you check your the data dot head, and if you run this here, if you see, all of your features has been transformed into numeric form, and now you can supply or give this data to your machine learning models as they are doing some calculation at the back end, right? They are performing some mathematical calculation, and then they are giving you this result as 0 and 1. So you have to feed in this numeric values. All right, so we have done this. Now the next step will be to separate your independent and dependent features. All right, so in X we are going to have our independent feature, and in Y we will have our dependent features. All right, so here we can give this X. So here let me comment this. So separate independent and dependent features. All right, so here we are going to have this X equals to data dot drop our, what is the dependent feature here? Survived. So apart from this survived, we are going to have all the features in our X. All right, so here we are dropping this survive only. So data dot drop your survived column, and also you have to give this axis, otherwise it will not know whether you want to drop it something axis, that is your features or your columns, or you want to drop the rows. Right, so it will not know until you specify this axis here. So we have specified this axis equals to 1, and now y equals to data, and in y, that is our, in y we are going to have only this dependent feature. And here what is our dependent feature? It is zeros and ones, right? So here I'm going to give this survived only. So let's run this, and now let's run it using our keyboard. Press shift and enter, and we have separated this x and y. If you want to have a view, you can have this view using this head. Let's have a look here too, right? So here you have p class, text, age, sib sp, parts and pair. Then you have this embark, right? And in your y, to check your y, just have this zeros and ones. 0 means that the passenger died, and 1 means that the passenger survived. All right. So now that we have separated this dependent and independent feature, the next step is to have a different data partition. One is going to be used for our building our model. All right. So one is going to be building our model, and the other partition of this data set, whole data set, is going to be used for evaluating our model. So here split the data into training and testing. All right, so we are splitting the data into training and testing, and to do that we are going to use the sklearn package. All right, so what is scikit-learn? I hope many of you must be aware about that. Scikit-learn is the library in Python for machine learning, and if you want to read more about this scikit-learn, you can go to its official documentation here. So sklearn or scikit-learn, and just write documentation, and here if you just Google it, it will take you to this first link. All right, so just click on this first link, and here you will be able to read about all the algorithms that you can apply using this scikit-learn. Not only the algorithms, but also different pre-processing techniques as well, and also the scientific computation here, right? So you can go for classification, regression, clustering. So you have all the support here provided for you. All right, so you can go and read about this scikit-learn package, and the best way to learn these packages is through their documentation. All right, so here we are going to use this scikit-learn for splitting our data in training and testing. So here we are going to import the package first. So from sklearn dot preprocessing, right, we are going to use this package which is sklearn. From sklearn we want this preprocessing, import train test, train underscore test underscore split, right? So here if you want to read about this, you can go to Google and just type sklearn train test split, and here you can go to this first link, and you will have the all the documentation how to implement this. And if you go down, you will also see some of the examples written already. All right, so here by using this package to split our data into training and testing, so here I'm going to write x train comma x test comma y train comma y underscore test equals to train test underscore split, and here I have to give this x which has our independent feature and our y. All right, so here we have this x and y, and then you have to specify the size. Let's say if you want to have 80% of your data for training and 20% for testing. That you have to specify here. All right, and you can specify that using this test underscore size equals to 0.25. So I have given 25% for testing and 75% for training. All right, and also you have to give this random state. All right, so every time you run this model, you are going to have the same output, otherwise you will get some other result. All right, so random state equals to 40, and now run it. So there is some error here, cannot import name train test split. Check that. Sorry, it's not pre-processing, it should be model selection. So there is a small error here, it should be from sklearn dot model underscore selection import train test. Right, now it will run fine here. All right, now let's get some new code cells as well, and here let's check the what is in xtrain, ytrain, xtest and ytest. So xtrain has all the independent feature and your ytrain has your dependent feature for your training data. And if you want to check the size of your training and testing, so let's check that here as well. Check the shape of training and testing. All right, and here we can give this print x underscore train dot shape comma y underscore train dot shape. All right, and similarly let's copy this code cell and we will paste it one more time here. So just paste it over here, and here in place of this xtrain we have to give this test. So x test and y test. All right, let's run this. So we have this x test, y test here, right? So we have 6, 6, 8 and 7 features. So 6, 6, 8 rows and 7 independent feature, and in y train we have this 6, 6, 8 classes to predict. All right, and for testing we have 223 data points. All right, now let's build our model. So we are going to build our logistic regression model, and we are going to use this scikit-learn package here. So you don't have to write everything from scratch. The help is already provided from these packages. All right, so all you have to do is you have to import these packages, and you should know how this works at the back end. All right, so here let's build our logistic regression model. So logistic regression model. All right, so here let's say you have to first import it. All right, so you can always go to Google, write the package name and then documentation, and click on the first link. Always you are going to be taken to your documentation, official documentation for that particular package. So here we are going to build this logistic regression model now, and we are going to use this scikit-learn package. Right, so here I'm going to import the package first. So from sklearn dot linear model import logistic regression. Import logistic regression here. All right, now we are going to create a instance of this logistic regression model, and here I'm going to name it as LR underscore model. Right, so we have this linear model, so let's keep it LR model, LR underscore model equals to our logistic regression, and we have this instance of this logistic regression. Right, and next we are going to so here we are going to build our model. All right, so linear model, so LR model equals to logistic regression, and then you have to fit this data. So LR underscore model dot fit. So here we are going to fit this training data here. So fit your x underscore train comma y underscore train. So we are building our model on this training data. All right, so let's run this. So here you are getting some warning, that is convergence warning, and it says total number of iteration list reached limit. So here you have to make sure that you do this scaling of your numeric feature. So here you have to scale this age and fair. If you don't do it, it is going to work fine, but you are going to get this warning here. All right, so it doesn't matter, it has built this model, and now we are going to check the how well our model is working or doing the prediction. All right, so here we are going to predict and check the evaluation or evaluate how well our model is doing. All right, so to do that you have to import some packages matrix to evaluate your model. So from sklearn dot matrix import, so import your confusion matrix. Sorry, let's import this plot confusion matrix. So we will directly plot this. Then also import this accuracy score. All right, so we have this accuracy score and confusion matrix. All right, and first of all you have to do the prediction. All right, so here you have to give the prediction. So prediction on training data and then prediction on the testing data as well. Then only we will able to see how well our model is working for training and testing. If both are the same, you're providing the same accuracy, then we are fine with that. All right, so here prediction, do the prediction here. So here I'm going to write, comment this prediction, and here we can give this tr underscore predict, that is training prediction, equals to lr underscore model dot predict. Right, you can also have the probabilities. Right, what is the chance or probability of person dying or surviving. All right, so you can have the probability. Otherwise if you just give predict, then by default it is going to take the threshold of 0.5 and give you the direct classification as 0 and 1. So here let's do that and see. All right, so tr predict, and here let's predict this for x train. Right, and now if you see your tr underscore predict, let's run this. By default it has done this classification. All right, so this is your prediction result for your training set. And here if you give this, you want the probability, then in place of this predict you can give predict underscore proba, and here will give you the second proba. There is spelling typo. dot predict proba, and here your x train. All right, and here let's run this, and this time you are going to have this probabilities, right? So this time we don't have the direct classes, so you can do this predict or predict proba, and if you do predict, by default the threshold is 0.5. so here you have this two columns here. All right, so here the first column is for 0 and the second column is for 1. So this is your chance of dying, and this is your chance of or probability of surviving. And here if you see, the probability of dying is more than 0.5, right, and it is more than this 0.47. so that's why if you see, the first value that we had was 0. So here we are going to use only predict for our purpose, right? So we have done this prediction for our training set, right? And similarly we do this prediction for testing set. So let's call it as ts predict equals to lr underscore model dot predict, and here you can give this x underscore test. So this is your testing prediction. All right, and let's run this. All right, so we have done this prediction. Now the next step is to evaluate, check some metrics here, right? We haven't checked how well this is working. So you can either plot this confusion matrix, or you can check this using accuracy score. So let's check it using accuracy score. So check accuracy score here, and here we are going to write print training accuracy, and here we are going to give it accuracy score of our y true. So y true is stored in our y train, right? And we are doing this prediction and storing it in tr predict. So it is going to compare these two values and give us this accuracy score. All right, so how many we were able to correctly identify. All right, so this is our accuracy score for training set. And for testing set, copy this line of code and enter, just paste it, and then change this to testing accuracy. I'm going to write it as testing accuracy, and here accuracy score by test and our ts predict here, and it is going to give us this accuracy score. So let's run this. All right, so here if you see, we are getting the training accuracy of 0.79, right, and also the testing accuracy of 0.798. These two are close, right? There is no much difference between training and testing, so our model is not overfitting, and also it is doing a quite a good job at predicting whether the person is going to survive or not, right? And if you want to see actually, then you can also plot this confusion matrix using this plot and confusion matrix, right? And here you can give lr underscore model. This is our logistic regression model here, right? And then you can give your x and y. All right, so we are going to give our x train comma y underscore train, and this is going to build a confusion matrix here. And here let's format it, comma, give it value format, a value format, and here you have to give this value format equals to t, and now it will run fine, and now you can compare this. All right, so this is our confusion matrix. What does this confusion matrix tells us here, right? So here this is our true level, right? So on y axis we have true level, and on x axis So here we have this value format equals to D, right? And to run this, we have this confusion matrix, and now on y-axis we have true labels, and on x-axis we have the predicted labels here, right? So now you can compare that this is the true label which is 0 and the prediction was also 0. Similarly, you can compare this, these two values are misclassified. So we have 57 plus 78 misclassified points, right? And our model is doing good job. So we have 358 and here 175 values which is correctly classified by our model. So we are fine with this model. All right, now that we have built our model, the next step, what should be our next step, right? So you can go for parameter tuning. Yeah, you can do that, but don't leave your model in your notebook only. All right, so it will do no good if we just leave this model here after doing all these hard works. If we are not utilizing it in our daily life or day-to-day life, then what is the use of doing all this hard work here, right? So it should add some value in your daily life or in your business life if you have prepared this for your business purpose, right? So for that you have to save this model and then make some web app or something out of this model here, right? So we are going to save it and build a web app where it will predict whether the person is going to survive or not based on all of these parameters, right? So you have this P class. So if someone enters this P class as 1, 2, 3 or this gender as male and female, then this age, CBSP, parts, pair and embark, then your model should be able to tell that whether what is the chance of person surviving, all right, whether that person is going to survive or die. So to do that you have to first save your model. So we are going to pickle our model here first. So pickle your model here. So we are going to pickle our model. All right, now pickle it. First of all, we have to import the package which is pickle. So import pickle, and then you have to open a file here. So here we are going to write with open and here the file name. All right, so within parentheses and quotes we are going to give file name dot pickle with the extension of dot pickle here. So let's give it as logistic model, or let's name it as Titanic model, Titanic underscore model dot pickle, right? And here comma, to give this we want to open it for writing some data, right? So you have to give WB, which is for write binary, and as F. So we have opened this file. Now the next step is to dump this file, our classifier, in this file that we have opened here. All right, so you have to write pickle dot dump your model name. So what is our model name here? It was LR underscore model, right? And comma F. So we are writing this in F. All right, so in our Titanic model dot pickle, and let's run this. So shift enter, we have run it, right? Now where is my file saved, right? Where is my file saved here? So your file is saved here. So you see that here you have a new file which says Titanic model dot pickle. All right, and here from here you can download it and use it. So we will download it, but first of all what I would like to mention is make sure that you have some kind of distribution installed, Python distribution, either Python idle or VS Code or Anaconda, then only we will be able to deploy or build some web app from this model, right? So here you have to download this. If you don't have it downloaded any environment or navigator, don't worry, you can do that and you can access this video. So you go through this video, download it, and then do all the tasks that we are doing right now. So before downloading this, make sure that your packages in this notebook, which is Jupyter notebook, here we are using, and whatever package you have installed in your system are matching. So here if you see this scikit-learn package that is used here in Google Collaboratory, so let's check that. So here let's move this and go down and let's check the version of scikit-learn, right? So check the version here, and to do that have to first import sklearn. So we have imported this sklearn. So here we have to check the version first. All right, check the version. We have imported this scikit-learn, and the next step will be to check the version. Now how do we check this version here, right? So to check the version here, you can give, so here you just have to write print your sk dot underscore version underscore, and it will tell you the version, right? So here the version is 0.22.2, right? So this is your version. So we should have checked this before building our model here. All right, so no worries. So here we have this 0.22, and let's go to our VS Code which we are going to use here, right? So here I'm going to go to this VS Code, and there we will build our model. Let's go to VS Code. So it's opening, it will take a while. All right, so now we have this VS Code here, right? So we have this VS Code, and here if we see, I am in this folder which says Python scripts, and here I have hello world.py, right? And here we can check the package of scikit-learn, so like we do in the script. So here make sure that the package that you have in VS Code and the package that has been installed in your Jupyter notebook are same, or the collaboratory that he is using are the same here. So here I'm going to write print. So first of all import sklearn as sk, right? And again what we will do is we're going to check the version. So print version, so sk dot underscore version, and then underscore. All right, now you have to save it to run it. All right, so in VS Code first you have to save it, then only you can run it. So Control S and it is saved. And here in terminal you can write Python and your file name. So here it is hello world.py. So hello world underscore world dot py and enter. So it will take a while, and here if you see it says 0.23.2. all right, and in our notebook if you see the version was something else, it was 0.22.2. so it is using an older version here, right? So first of all, make sure that this version are same, and we are going to install this version here. So first of all, you have to run all this model again, no problem with that, right? So first of all, let me remove this from here and delete this file. All right, and now to install it, just click on runtime and just factory reset your runtime here, right? And you try to install, check these packages before and only. All right, to give you a demo, I was using this here only. Right, now how do we install this scikit-learn package? All right, so here you can write pip install, right? So we are writing pip install and then hyphen u, then scikit-learn scikit-learn, and here you can give the version that you want to install. So here we want to install this 0.23.23. now let's run this one by one, right? And now it is going to install this version of scikit-learn here. So let it install, it will take some while, and now it has successfully installed this package. Now go to runtime and click on run after, and it will run all the below cells that are there. All right, so let's check that. I think we have run it and we have saved our model now. So yeah, we have run everything, and now we have saved this here. All right, it is Titanic model.pickle. Now let's download this. Click on download, click on dotted arrow here, and then click on download, and here it has been downloaded. So click on here and go show in folder. You have to take this to your folder where you have stored all of your VS code. So I have it in my documents and then Python scripts, and here I'm going to paste it, right? So I have Titanic model.pickle here. All right, now we are going to build a app using this our model. Here we have saved this Titanic model, right? We are going to use it and we are going to build a web app here, which we will be hosting it locally. So here to do that, we are going to use some packages, and here we are going to use the Streamlit package. If you want to read more about it, you can Google it. There are very nice documentation, and it is way easier than any of the packages or framework that you use. So import Streamlit as st, right? And again import from sklearn dot linear underscore model import logistic regression. All right, so you have imported this two packages, right? So now to run anything or write anything, let's say here if I want to write anything on my web app, here I can give st.write, right? And here if I give something, let's say I give here hello, and here let's save it. To run it you have to save it, so Control S, and here if I go to terminal, and here you have to write Streamlit in your terminal, Streamlit run hello underscore world dot py, right? And enter. So if you press enter, it is going to run a web app. So first of all, let's build all of this web app, then we will move forward with it. All right, so here let's run this. So let's make it run it one more time and see what does this does here. All right, so here I can run it, streamlit, run hello world dot py and enter, and let's see. So just a second, it is taking some while, right? And it's a Windows firewall, so just allow access. And here you have a web app running in your browser, and here it says hello. So you have given st.write, and here it says hello, right? And also if you want to add title, we can do that. So here st.title, right? Title, we have this welcome to CodeGnan webinar, and you just have to save it. Don't have to run it now, just go back, and here if you see it says source file changed. So you can rerun, or you can click on always rerun. So I'm going to click on always rerun here, and here you have this welcome to CodeGnan webinar and hello. So there are many more things that you can do using this Streamlit. Let's not talk about that. We're going to build our web app for our model. All right, so I'm going to remove this, and here I'm going to import pickle. So import pickle, and then you have to open this file. So you have to open, so with open again, and here you have to give the name of the file, and here we have stored this in Titanic classifier. So what was the name? Let me check that. So Titanic model.py. So here let's give it Titanic underscore model dot pickle as. So here you have to give now RB, that is you want to read this file now, and when we were writing, then it used to be WB, right? And here it is RB as F, and now you have opened this file, and next let's store this in classifier equals to pickle dot load F. All right, so you have opened this classifier now. Now the next step is to take some input and build our model here. All right, so here I'm going to define a function. So def main, this is going to be my main function here, and also I want you guys define if. Here you have to write if underscore name is double equals to, so underscore main, then this is going to run, this app is going to run. All right, now I have defined a function here, right? And now we are going to build our model. So here if you see, we have applied 7 features here, right? So you can do that, and to do that, here you have to create some check boxes or select boxes here, right? And we are going to do that here. So let's do it. So let's check the features that we used here. So let's close this, and the first feature is that whether he is male or female, right? So we are going to check that. So here you can write st dot sidebar. So in sidebar it is going to appear dot select box, right? And here you can give the name. So we want this gender, and here you can give it as comma, and here you can give male comma female. All right, and now if you save this, just save it and see what changes do we have here in our web app. Right, so here we have this web app, and here you have a sidebar to choose whether it is a male or a female, and your app is running. So we want to select this male and female, whether the person was male or female. All right, now let's head back. Similarly, we are going to do it for all other features. All right, so if so let's store this here in a variable. So we are going to name this variable as, let's say, this is our gender. All right, so this is our sex, whether male or female, and we have this. And now if sex is double equals to male, then your, okay, and here it is going to be gender going to be equals to 0, as we have encoded it as 0, right? And else, if it is else, it is going to be gender equals to 1. Let's save it and see. So here you won't be able to see any such progress because we are just writing this command here. After we build all this app, then you will be able to see. All right, so let's head back, and I'm going to copy this. So we have 7 features, right? So you have to do this for all those 7 features. So let's go back and paste it over here. After our text, what do we have here? So here, let's go up. We have this age. All right, then CBSP, and we have P class, right? So what was the P class? It has 3 values, 0, 1, 0, 1, 2, 3, I think. So let's check whether it is numeric value. So I think it is numeric values, so we can do that. Give it here. So let's give it here. Remove this all, and here let's give it as your P class equals to st dot sidebar, right? So in sidebar we want this, and in sidebar it is going to be a text input dot, sorry, it is going to be a input number. So number input, and here you can give this name. It is your P class, right? And if you save it, Control S, and again if you go back here, it's running, and now you have this P class where you can enter this values. Similarly, we are going to do it for other features. We have this P class, and now what was the other one? Let me check that. After P class we had this age. So age is going to be your numeric feature as well, and fair is numeric as well. So here I can give this age equals to st dot sidebar dot number input, and it is your age. All right, and next we have here is our fair. So fair, so just give it fair equals to st dot sidebar, right, dot number input, and this number input is going to be your fair. All right, and now we have this age, fair, P class, gender. So we have this 1, 2, 3 and 4 features. Let's see what are the other SIB-SP, parts and embed. So you can have this as your numeric feature as well as your select box. So you try out. I'm going to, for simplicity, I'm going to give it as in text features. Sorry, this number input only. So we are going to have this fair. After fair, we had this. What was the name? Embarked. So embarked equals to, let's say, st dot sidebar, and here dot number input, and here you can give this embarked. So embarked. All right. So next, after embarked, we have this parts and SIB-SP. So let's give it as well. So parts equals to st dot sidebar dot number input, and here you can give this as parts, and then number of siblings. So SIB-SP equals to st dot sidebar dot number input, and here it is going to be your SIB-SP. All right, now we can give all these inputs here, right? So just save it, Control S, head back to your browser, and if you see here, it's running, and you have all this in sidebar where you can give all these features, whether it is male or female, then what is the P class, then age, then fair, embarked, part, SIB-SP, and all these features here. All right, so this is our independent features. Based on this, we are going to predict whether the person is going to survive or not. So we have 1, 2, 3, 4, 5, 6, and all the 7 features here, right? And if you want to customize, you can do that. You can read about this streamlit. Let's predict now. Our next task is to predict. So if I think there was some technical issue. I'm so sorry for that. Move that. All right, so we have seen it, right, that we can build this. Now we are going to predict. So here we have written this, if st dot button, and the name of this button is predict, and if you click this button, then our classification should happen, right? So here class classifier, or survived or not survived, equals to, is going to be classifier where we have stored this pickle. So where we have stored this pickle in classifier, right? We are going to write classifier and then go down here, classifier dot predict, and here you have to give all these values. All right, so here you have to give your all the values that you have given when building your model here. So if you go here in X, we have this P class, right? So you have to give here your P class, and here our P class is stored in this P class here. So let's give it as P class, comma, then you have it after P class, it is age, then 6. So here we have age, then comma, we have 6, comma, then we have SIB-SP parts. So SIB-SP comma parch, it is parch comma, after parch we had embarked. All right, so it is embarked, and you are going to do a prediction. All right, so here let's go back to our browser here, and here we have this app. Refresh it again, rerun. So there is some error, that's why it's not running. So you have to save it and head back and always rerun. So it's running. Here you can see that it is running, and here we are doing this prediction, but you have to write it as well. All right, so here just give this a title. So we are going to give this title here first. So after this, get a new cell and st dot title, and here Titanic survivor prediction. Right, and here we can give this class. All right, and here we are going to write it over here. I'm going to write st dot success, so st dot subheader dot success, and you give this survived. All right, let's save it and head back, and still running. All right, so here let's give it some value. All right, so we have male, and here I'm going to give this p class. So let's say I give this p class here as 3. Right, so I'm going to give this as 3, and age, let's say I give it 14. The age is 14, let's say, and then let's say the fare was 149. Right, and go down and embarked. So I embarked from, let's say, first destination, right, and number of parts, let's say it was 0, and CBSP was also 0. All right, so we have filled all this information here. Now what? All right, so you close this, and here you have Titanic survivor prediction, and here you have a button. So if I click on this button, predict, let's see what will happen. So I think is capital, we have made some mistake here. So let's head back. Yeah, it should be small, right? And then save it, go back, go head back now, rerun, and we have information already supplied. Click on predict. So yeah, it's going to have 2D array here, so you have to give 2D array here as well. It's 2D, and save it and go back, and it's rerunning again, and click on predict. So initially there are going to be some errors. So X has 6 features per sample, expecting 7. So how many features do we have here? 1, 2, 3, 4, 5, 6, and 7, right? And here we have given 6 only, I think. So here we have given P class, age, sex. So 1, 2, 3, 4, 5, 6. What one class we have left here? Take that. P class is given, age is given, sex is also given, best parts, pair. So we haven't given pair here. So let's give it. You have to give all the variables. So fair. Yeah, now let's save it, head back, and now this should run fine here. Click on predict. So we are getting some error here, that is data type error. Let me check that. just head back. Let's head back, and here let's have this. Let's go up. Have to change this. Let's have this as input feature, numeric feature only. Move this, and here st dot sidebar dot number input, and here let's give it as x, right? And let's save it. Control S. Let's head back, give some value here. Is this, do that. You can also give 1.0 here, so let's give it 1.0. then your age is fine, pair is fine, right? Let's go down, embarked, and predict it now. P class is not defined, so let me check that. Here it is P class, and here 1, 2, 3, 4, 5, and 6. We have not given this P class. So let's give it P class equals to st dot sidebar dot number input, and it is going to be your called as P class. Save it again. So head back and check it. Run fine this time. All right. So it is running fine now. I have just made a small mistake here. So let's remove this. Yeah. Now save it, and going to work. Right. So here the output says the class is 1. All right. Means the person is going to survive. And also, if I give some other value, here I have this as 1. If you want, you can change this to 1, 0, that is survived and not survived, simply by writing if else statement. So if the output prediction is 1, then the person is going to survive, else the person is going to not survive. All right. And if you give some other values, let me change it here. So here let's say P class, give it as 1, and let's give sex as 0, and here your age, let's change this to 59. All right. And we have changed some value. Now if we do some predict, again you are going to get this 1, but you are going to get different values, that is 1 and 0. Based on, you go on and play with this all values and see what result you will get. So we have built our model, and also we have deployed it, right? So we have done a pretty good job, right? And if you see, there are many people who know how to build these models, good models, but these models resides on your laptop or in your notebook only. You don't see it used in the real world. So you can use it here, right? You give different values here and try to play around with it. So it will be shared with you all. Don't worry about that. You'll get all these recordings and files. All right. So now we have built our model and we have also deployed it. I hope you all enjoyed this session. And again, on Sunday, we are coming up with another session on decision tree, and also we'll be deploying that model as well. And for any future updates or to participate or to increase the engagement, to learn in a fun way or engaging way with our group that is already there, that has been trained, there are many experts in that group as well, which are going to help you with your different queries. So I recommend you to join our Facebook group, and that is surely going to help you learn this machine learning, how it is really used in real world, not just the Jupyter notebook one, right?